Thanks so much. Hi folks, I'm Christian. Today I'm going to be talking a little bit about WebAuthn. So hopefully a little bit less about passwords, a little bit more about authentication. I have this weird South African mixed with US accent going. I normally spend about an hour on these slides. I've tried to trim them down, so I'm going to be going through it really quickly. If you struggle to understand me at any point, please help me by raising your hand and saying, slow down, please repeat what you said. I'm going to try and speak as clearly as I can, but help me by just pointing out if you have no idea what I'm saying or talking about. Okay, so web authentication and security keys, unlocking the key to authentication. So we've all heard the news, right? Earlier this morning, we have seen multiple presentations on this. Passwords are broken as an industry. We're trying to do something to fix them. Users are struggling with password complexity. In some cases, we don't even know how to compute password entropy, right? It's hard. All this stuff is incredibly complex. Can we do something to help our users? Can we do something to fix this as an industry? Some statistics here. Google has done a study. I think this is from a fairly old paper that we've published. About 43% of users still fall in this day and age for the good old phishing scams, right? We spoke a lot about, ways to, pick good passwords and make sure even in online attack scenarios, if someone gets hold of a password database, if it's not salted or not encrypted or not hashed, we have a good, very complicated password set. I guess it has to be hashed. You still can't be broken into because you've got a great password that you've chosen. What if you are simply in the middle of getting phished? Doesn't matter what you've chosen at that point in time, you are vulnerable. And this is the biggest attack that we currently see at Google. And the thing that we are most worried about is about plain and simple password phishing. And the rest of the presentation will talk a little bit more about why we believe this to be the case. So 43% of users still fall for well-designed phishing pages in this day and age. 81%, I guess, of account vulnerabilities last year were due to weak or stolen passwords in some way, shape, or form. And then we've got a couple of statistics here that I want to talk about really briefly, right? So about 3.3 billion account, credentials can be found online. We started last year, used the Google search crawlers, changed them a little bit, tweaked them to index the web, but specifically look for username password combination pairs. And what we found was pretty disturbing. Like I said, about 3.3 billion unique usernames and password pairs online. Now, just to be clear, these weren't stolen from Google. They were stolen from many other third parties in breaches. But unfortunately, these credentials also get reused, as we know. So some of these were actually valid for Google accounts as well. And we've seen that about 17% on average from the study that we've done, these credentials seem to be reused, but we think in practice it's actually much more frequent than just that. Luckily, we've worked to secure proactively about 67 million of these. Of course, if you have them, you can test them against your own account base, and if you see they succeed, you can let the user know, hey, something's up here, please go ahead and change your password. But the problem is many other services might not be as lucky. So the goal of this presentation is to talk a little bit about what we can do to move beyond passwords. I'm hoping that this stuff isn't science fiction. I'm hoping there is things in here that's really actionable even today for website developers and other folks to actually start playing with and implementing, but we'll get to that as we go along. Now, the typical marketing slide, I'm normally told to add this in here. It's not all bad news. There's a lot of things you can do proactively, even about, we normally say over 99.9% of the times when someone comes with a valid username password paired to Google, there's ways that that this isn't from the legitimate user. Like if this is a botnet kind of, harvesting these credentials and trying them out one by one, there are certain patterns that you can detect. So many times, even if someone has a valid username and password for an online service, we do it, other large service providers do the same. Maybe you've got the same thing implemented on your websites, but there's ways of detecting, even when you have valid usernames and passwords, that this isn't coming from the legitimate user. What I'm here to talk about today is that 0.1% of the time when we cannot identify those attacks. What do we do in those cases? So the industry has come up with a solution here. We call it multi-factor authentication. As we all know, two-step verification, MFA, whatever your favorite terminology here. Good contact guy called Troy Hunt who you've probably heard about, runs Have I Been Pwned, just published an article, I think about 2 or 3 days ago, fantastic article on the difference between 2FA, MFA, and also a program that we run at Google called the Advanced Protection Program. I'm not here to talk about that program particularly today, but if you're interested in this stuff, which I think most of you are, it's a quick read, maybe 5 or 10 minutes, maybe on the plane ride back or the bus or whatever. Take a look at that article, really, really fascinating stuff. Anyway, industry has worked to try and protect us, from password issues by introducing multi-factor authentication, but we know MFA in the current world where we are today isn't really that great. We've seen earlier today, retyping codes from one device to the next. All these things kind of just add hassle, and they really don't solve the fundamental problem, because all of these technologies fundamentally are still phishable. So we're not ultimately protecting ourselves against that threat that we've identified as like the number one thing for us. What is the sources of stolen passwords? Phishing, number one, and we'll look at that in a second. Keyloggers, data breaches, we all know the story here. Now, the thing is, what's really interesting here is, depending on if your account details were stolen, got exfiltrated from a breach, or if you had a keylogger installed, or if you're actively being phished, the chances of you actually being hijacked and your account being hijacked increases fundamentally from breach to keylogger to phished. And this is again why we are so worried about phishing in particular. Users that are phished 500 times more likely than anyone else to actually have their accounts compromised. So phishing really, really important for us. We know it's really easy to get these online kits. I usually have a demo. I'm not going to go through that today. I think you all get the fundamental problem here. But even online MFA technologies such as retyping one-time passwords, or even getting push-based authentication messages on the phone, even those are ultimately susceptible to phishing, right? All the bad guy has to do is implement a we call it man in the middle. It's not really man in the middle in the true TLS sense, but implement a server sitting right in the middle, redirects the user there, get them to enter their username and their password, get them to approve the message that goes to their phone, or get them to enter the OTP, and that bad guy actually, logs in as you right there in the session. So these things aren't hard. Evil Engine X, you can download it today. It takes about 10 minutes to set up on the cloud provider of your choice, or you can just go and grab these tools from the underground web. Essentially, these things are widely available, and pretty much anyone can use them. What's interesting here is phishing is still working, right? We think about phishing and we think this is a 10-year-old problem, who cares? Phishing isn't really the thing online anymore that, causes anyone any headache. But it's interesting to see that, phishing is so successful that the general malware market has actually died down a lot. And I pulled this, it's a little bit maybe 2 months old here. But it's interesting to see from when we started capturing safe browsing data on Chrome, where we report on, malware sites, phishing sites, and other general bad stuff on the net. It's interesting to see that we had a massive amount of malware sites initially, and that's been overshadowed pretty much by phishing. So just something to kind of keep in mind, right? To or kind of emphasize that point that online phishing is still a massive concern for us. I'm going to skip over some of these slides. They are a little bit less interesting. Just typically, where these things come from, where the accounts typically originate. United States, interesting. My home country, South Africa, being number 2nd. I don't know about that, but anyway, takeaway here is billions of passwords available to hijackers, and account hijackings are professional. This is something that's being run as a business, and as an industry, we really need to figure out a way to kind of combat this. And I guess that's what we're trying to do here with technologies such as web authentication and FIDO. So before I go any further, maybe raise your hands if you've heard about WebAuthn or W3C web authentication before. Oh, that's great, fantastic. FIDO, same hands? Okay, fantastic, cool. So here to talk a little bit more about that in particular, and maybe there are some things here, maybe you all know this already, but some launches that we've recently done. Chrome 70 is, I guess, kind of the latest one that we've pushed out, where some of these tools and web authentication mechanisms are now available to you as developers. So I'll talk a little bit more about that as we go along. So we started at Google. Let me go back one slide. We started at Google by not trying to replace the password completely, but simply by trying to make the use of the password safer. This has been the goal of multi-factor authentication or two-step verification for a long time. We're not trying to replace passwords, we're trying to make them safer. And this is typically where we started off with something called the security key. Most of you, I'm sure, if you're familiar with WebAuthn and FIDO, you know about this thing called the security key. I actually have about 30 of them in a little box here. This session is more popular than I thought, but if you're interested, after come up and feel free to grab one until there's none left. This is the Titan security key that we've released at Google a couple of months ago. It's in all respects, kind of virtually the same as any other U2F type device that you can buy. And we'll talk a little bit about what U2F is and how it works here in a second. It's meant as a second factor. You already have your username, you already have your password. You don't have to now, accept a push message on your phone or type in a code from somewhere else. You simply insert this into your USB port or tap it on the back of your phone using near-field communication, and that is your second factor. What is the big difference between this and all other second factors out there? The fact that these things are really, really hard to phish. Even if you're going to a website which is not the legitimate websites, everything checks out. You enter your username, you enter your password, you plug the thing into the drive, and you click the button. If that's a phishing website, chances are that the security key will not allow that bad website to log in as you. And we'll talk in a couple of slides here on how that is and how that works in more technical detail. And then don't worry, we're not only going to be talking about these physical security keys. I realize this is probably for about 0.001% of the population. What's much more interesting to us is how can we use the technologies that everyone has with them today, things like their phones, their laptops. These devices are coming out with embedded biometrics nowadays, fingerprint scanners, other things. How can we use those enable devices in a seamless way for online authentication? iPhone, I guess, has pioneered some of this stuff with the release of the iPhone 5S, where for the first time we had a fingerprint sensor in a consumer device, which was widely accessible to any application. Problem is, up until this point, that fingerprint sensor has only been available to native applications. What about the web? This is where web authentication comes in. So a little bit of a sneak preview, but we'll talk more about that in a couple of slides here. So anyway, security keys, what do? They allow the server to know which URL you're pointed at. So if you're not pointed at the actual website that the server expects, in the case of Google, accounts.google.com, the security key kind of is a little bit of like a canary in the coal mine. It'll tell the server that you're pointed at the right URL, and if you're not, the server will not allow the login to proceed. So we'll look in more detail about how that works. So it's based on asymmetric cryptography. There is a private key on the security key. This is pretty much the FIDO U2F standard. Any developer, any vendor can build to the standard. It's completely open. Great company called Yubico, based here in Sweden, also in Palo Alto, builds keys that does exactly the same thing. About 30 other vendors out there building these keys. Private key on the device, public key sits with the server, and when you're trying to sign in, you're simply proving that you have possession of the private key to the server. In addition to doing that, you're also telling the server which website you're on. That's the important part, and that's what we have for the kind of phishing resistance here. So how do they work? Let's quickly step through this. When you're trying to sign in, you send a challenge from the server to the client, and at that point in time, the kind of browser intervenes, and the browser says, hey, which website is actually trying to authenticate right now? So we look at whatever URL is in the browser, we call it the origin, or I guess the web calls it the origin. So look at the origin, we send the origin over the local USB, NFC, or BLE communication bus to the security key. The security key uses the private key that it has, constructs a digital signature based on that private key and on the calling data, sends everything back to the browser relays it back to the server, and once everything matches up, once we see our challenge, once we see our correct origin, once everything is signed using the correct private key, then the server says, cool, we're happy with your username and password and your security key assertion, you can now log in. So that's basically what this whole FIDO U2F situation has been all about. So it allows everyone that has one of these security keys and is okay with the hassle of carrying them around and using them whenever they have to log in, it allows them to have the added benefit of strong phishing resistance. Even if you're on a website that's not the real Google or the real Facebook or the real Dropbox, any one of these that implement the protocol, even if you're on those websites and you're trying to log in and you're using your security key, the website will know you're being phished and you will not be allowed to log in. So pretty simple. The technology is created with open standards. You might have asked yourself the question, or maybe you already know, what is FIDO, what is WebAuthn, how do these things relate to one another? Well, the idea here is that we have two sets of APIs that's both open in play here. The first one that's very important is the API between the server, the website, and the browser. That is being standardized in the W3C, in the World Wide Web Consortium, and that API is called Web Authentication. It's a JavaScript-based API, and that is how a website basically talks to a browser and says, hey, I want to talk to some security key thing. The cool thing is, it doesn't only have to be a physical external security key, as we'll see in a second. We can also talk to built-in security keys, which is now available on all Android devices, and with the release that Microsoft has just done on all Windows 10 devices as well through Windows 11. But anyway, we'll talk more about that. The second API, which is maybe less important to this group here, unless you maybe want to get into the business of building some of these tokens yourself, is the API that's specified in the FIDO Alliance called CTAP, the Client to Authenticator Protocol. That's what kind of defines the wire protocol between the browser and the security keys, and that's what allows all of these things to all work together. So for the rest of this talk, we're going to be focusing a little bit more on WebAuthn, but anyway, both of these things do exist. We started by trying to make the password safer with U2F, but we really wanted to go one step further. What will it take to completely eliminate the use of the password? As I said earlier, the security key is simply used as a second step or a second factor. You still have the username, you still have the password, and then you use the security key to log in. What if we wanted to make the world a little bit simpler? What if we wanted to completely get rid of the password? What would that take? Well, that's kind of what was embodied into the design of WebAuthn here as well. So we'll look at that. So what is WebAuthn? Again, just quickly, just showing up again here, you might have also heard the term FIDO2. FIDO1 was the protocol that we used to talk to things that can only be second factors. FIDO2 is the umbrella term for both the CTAP protocol and the WebAuthn protocol that allows you to talk to both external devices but also to authenticators or things built into platforms, like all of the fingerprint sensors we now find on Android phones, the Windows Hello face recognition we find on Windows 10 devices. All these things are on the device already, and we've gone through one of these revolutions once again, or actually a couple of times in our life here. 10, 15 years ago, a lot of laptop manufacturers started out by putting these swipe-based fingerprint sensors on laptops. Never took off. Why not? Because there is never a way for any web developer or any application developer to really reliably access this across platform. Now we're trying to do this for a second time. This time we're actually hoping that the plumbing is now there. The plumbing through WebAuthn exists, which will allow any developer on the web to firstly probe, to ask a machine if you have this technology, and secondly, if the machine says yes, then invoke this and allow the user to use these technologies, either as an additional add-on on top of a password, but in some cases even replacing a password. And the simplest way to think about this is, today, if you have a banking application on your iPhone or your Android device, you open up the app. First time you open it up, you type your username and your password. Next time that you come back, probably don't have to type your password again. All you have to do is take your fingerprint and put it in the back of your phone. Now, we didn't actually get rid of the password there. Of course, you still had to use the password to bootstrap or set it up, but we got rid of the irritating use of that password and having to retype it every single time you open the app. If we just succeed in doing that, we can now actually go to a world where that first-time bootstrap password is a really, really long string that you have to type once. You can write it down on a piece of paper, actually support that 100%, or use a password manager or whatever the case might be. But remember, you will only use that password once you get a new device. Of course, going forward, we want to move one step further to a world where you don't even have to use that password the first time that you bootstrap. But taking a look at some of the slides here in a second, you'll see where we kind of want to move with this. So the first step we've already taken. I guess the first two steps. Step number 0 was making security keys work on the platforms that we control. So security keys today, of course, work across all of the Chrome platforms where Chrome runs, Windows, Linux, Mac, Chrome OS. It now also works on Firefox and on Microsoft Edge, so that's really cool. The second step that we've taken is making the built-in biometrics work across all of the platforms, again, that we control. So today, if you have an Android phone, please go to the website webauthndemo.appspot.com. I'll show it on the screen later today as well. Play with that demo. See how that website can invoke your fingerprint sensor and kind of play around with that technology. Basically, it gives the website a way to interact with the local secure key storage on the device, or the local secure key store, and with all the biometric interfaces. And then the kind of one step beyond is, how do we then actually get rid of that password, even for the initial bootstrapping? Now, I'll talk about this too. How much time do we have? About 10 minutes, cool. So WebAuthn enables two two core user journeys here. The first one is we want to make things simpler for the user, and secondly, we want to make things more secure. Using your fingerprint sensor to re-log into your banking app on your phone isn't really making the world safer. You can always cancel out and still type your password. It's just making things a little bit simpler for the user. The idea and the intent here is that we want to do both things, right? We want to make things simpler and we want to make things more secure, and these two come at different levels of trade-off, and we'll talk about that. Two core user journeys, the way that we see authentication happen in general, right? The first user journey here is called bootstrapping. That is the user journey that basically enables you to bless a new device. Think about, if you have a Gmail account or a Google account, and you have a laptop, you've probably only ever typed your password into that device once, right? The first time you sign into Gmail, you type your password. That is when you bootstrap. That is the risky operation. That's when we need to get your second factor. That's where we need to make sure it's the right device owned by the user. Once you've bootstrapped the device, kind of the trust is now transitioned into that device, and we say, well, we now kind of trust this device going forward. Unless you're trying to do something really risky, like change a password or make a payment, probably not going to challenge you for a authentication event again. Take, a banking application, for example, or a banking website, things are a little bit more risky there. There's still a bootstrapping scenario. The first time you use a new device, maybe the bank asks you some silly things like, having to enter, your mother's maiden name, if someone still does that stuff. But the point is they're trying to kind of establish trust in the device. And then when you come back to the banking website the next time, you're still being asked to authenticate, but it's a less of a risky operation because the bank now already trusts the machine you're on. So for the first one called bootstrapping, that's where we need to have your second factor and everything else. For the re-authentication scenario, again, Google doesn't really use that very frequently, but if you're a financial service provider, you might. Every single time a transaction happens, now with PSD2 in Europe, you're actually required to do some of these things at the point of payment. You need to re-establish trust and re-make sure that the user is actually at their machine. This is the use case that web authentication with built-in authentication can kind of solve for us today. And Bootstrap is the one where the physical security key kind of comes into play right now. Again, as I said, we're trying to move to a world where even for bootstrapping, you don't really require that initial username or password, but that's something that we'll get to. So let's go through a couple of slides, and I tried to make this pretty graphic and pretty, explicit in how this works. We have our actor here, Eliza. Eliza is going to try to perform a couple of actions. The first thing she's going to try and do is she's going to try and sign into her bank, and she's going to start on her mobile phone. She banks with a bank called TriBank, and she has never used this banking website on her mobile phone before. So first thing she does is she takes out her phone, loads the sign-in page, hits sign in, and today we see the familiar screen, right? Enter your username, enter your password. What's new with WebAuthn is the bank, TriBank, is now able to query this device and ask the device in the background, hey, do you support WebAuthn? Do you perhaps have a built-in authenticator and a built-in biometric capability available? If the banking website sees yes, at that point in time, they can promo Eliza and ask her, hey, next time you want to sign into this device, do you just want to use your fingerprint, maybe not type your password? If you then say yes, then a key gets registered, and next time when Eliza comes back, we'll see the fingerprint prompt. Let's quickly look at how we make this work. And again, I can probably share these slides so you can easily take a look at this stuff. Otherwise, WebAuthn demo.appspot.com has all this source as well. This all is available today. If you are writing apps or websites for any Android platform, if you're writing stuff for the Mac platform that has the touch bar with the fingerprint sensor, your users are running on Chrome, all this stuff is available to you right now to use. The first thing that we've done is the banking website needed to know whether the platform actually supports any of these cool new capabilities. And you ask the question, is user verifying platform authenticator available? If it says true, cool, you can now go ahead. You have all this capability. If no, of course, you move on with your life. And hopefully, as we go forward over the next month, years, more and more platforms will say yes to that query. Once you've asked the question, then you can issue a simple command called create. There's only two commands really that's of importance in WebAuthn: create, make a new credential, and get me a signature. Those are the only two things you need to know about, apart from, of course, the ease UVA PAA query to figure out whether there is capabilities available in the platform. You have different options. I'm not going to go to the different options. You can look at the demo website for all of these. There you can specify, are you interested in talking to an external key? Are you interested in talking to a built-in key? Like, depending on your use case, you might want to flip these bits, but the website also kind of takes you through all this stuff. there is something called transports here. I'm not going to go into too much detail here. That is kind of what you use to say whether I want to talk to a USB device or a BLE device, or whether I don't care, or whether I want to talk specifically to something that's built into a platform. Again, depending on whether you're trying to solve for the bootstrapping use case or the re-authentication use case, bootstrap might require something external, because remember, if you want to bootstrap, it doesn't help to register a credential on this laptop if next time I want to use my phone to sign in, right? For the re-authentication use case, then you want it built into the platform specifically. So just a little bit of a kind of a primer here, or a glimpse into how we have these different options available that you can tweak. We try to expose just as much information as what is absolutely necessary, but not to overcomplicate the protocol here. So hopefully we've done an okay job here. And of course, this is all done in the open. If any of you are interested in this stuff, if you want to contribute, you have some ideas, WebAuthn, open organization, you can join in W3C, FIDO as well. I think there is like some nominal fee, but that's even waivable for folks that's interested in participating. So always happy to have more folks, contribute to do both of those standards bodies. Anyway, let's talk about Eliza coming back, right? Now we've created the credential. What happens next time when she comes back to that website? She clicks sign in. All that she needs to do, put her fingerprint on the sensor. That's a native biometric prompt, which you'll see if you run the demo website. Android serves the native prompt, touches the finger, and she's logged into the banking website immediately. So for the first time now, we're able to use all of the technologies that we have available natively on these platforms for the last 3, 4, 5 years. You're now able to access them all from the web as well. But this is only step one. So how did we do that? We issued the other command here called get, right? So we said create to make a credential, get to grab the signature later. What happens when Eliza comes back and she decides, I don't want to bank using the mobile website any longer, I want to download the app, right? So today, there is no sharing of data between a mobile app and the web. The authentication events are completely separate. You've got cookies on the one side and you've got local storage on the other, and these things don't mix. Perfect, cool. So what happens in the WebAuthn framework? Well, because these different applications or different services are owned by the same publisher, whether you're coming from the web or whether you have a native like application on the device, because we can kind of merge these two together and say they're both owned by the same party, TriBank in this case, we are able to do some cool things. So Eliza goes to the Google Play Store, installs the TriBank app, opens the banking app. What happens the first time when she clicks sign in? Android actually shows a local account chooser that says, hey, you already have credentials for TriBank on this phone. Why do you have it? Because yesterday you logged in using the mobile website, and we've actually created the credential for you right then and there. So all you now have to do is click on the credential you want to use, touch your fingerprint on the sensor, and you're logged in. So for the first time, there's sharing of data between the web and the native framework here. Now, okay, again, like what did we do there? Just did a normal get operation, and Android served a UI. And again, this stuff is standard. It's spec'd out in the specification, so hopefully all browsers will implement the same mechanism and have this local account chooser available. So the experience across all browsers would be exactly the same. Now here's the cool part. This is the part that we haven't really, I guess we've spec'd it out. We haven't really released this yet. Everything up until this point is fully released and you can play with this. This is the part that we haven't released yet. What if Eliza wants to now go to her MacBook Pro and she's trying to sign into TriBank there? She wants to sign in without a password. How would that work? So she clicks on the sign in button. At that point, she enters her username. Now TriBank knows that yesterday a person with this username registered a credential on her Android phone. Now, using BLE locally between the device and the phone, we're able to actually go to the mobile device and say, hey, do you have a credential locally available for this specific user? If the phone has a credential available locally, you touch your fingerprint on the sensor, and via local communication, so not via the cloud, but between the phone and the device, we actually send the signature back over CTAP, that protocol that we spoke about. And because everything is local, we've solved the remote phishing problem. Unless these two devices are physically present in the same location, there will be no way for the signature to work. So we send the signature back to the device. At that point in time, what's even cooler is web authentication on the local MacBook says, hey, I know you have a local fingerprint sensor here too. What about you register that as well? So now you register the fingerprint of the local MacBook, and then next time when you come back, once you've registered it, when she comes back to her MacBook, she doesn't need the phone again. She can just click sign in, touch your fingerprint on the local sensor that you have on the MacBook there, and you are all signed in. So that is basically my pitch. I'm not going to talk about this too much. I know I'm far over time here already. I'll leave you with this on the screen. If you're interested in trying any of this stuff, please feel free to go to these websites. If you're interested in security keys in general, please feel free to pick one up here. And if you have any more questions, please stop me in the hall. Thank you.